Okay, let's get started. Hey everyone, thanks for joining us for the C2 Smart webinar series. I'm John Patinos. I'm a project manager at C2 Smart. As you probably just saw, this is going to be recorded and it's going to be uploaded to the C2 Smart YouTube channel with all of our other webinars. If you have any questions at all through this presentation, you can use the Q&A button at the bottom of your screen, and we're going to answer them live at the end of the webinar. Today, we're joined by Professor Don MacKenzie, Associate Professor of Civil and Environmental Engineering at the University of Washington, which is part of the C2 Smart Consortium. Professor MacKenzie heads the Sustainable Transportation Lab at UW, which develops and evaluates technical and policy solutions to make transportation systems more economically viable, accessible, and environmentally benign. So today, he's going to be presenting his work on micromobility parking management, funded in part by the US DOT. Professor MacKenzie, go for it.
Thanks, John. Thank you for the intro, and thank you all for joining today. And I'm looking forward to sharing this C2 Smart funded work that we've been working on over the past year. Before I proceed, I really want to share credit with Chintan Pathak and Borna Arabkadri, who are two students in the Sustainable Transportation Lab and grad students in the Civil and Environmental Engineering department at the UW, who really have done the real legwork on developing and testing this mobile web app that we have developed. I also, knowing that I would have a bit of a captive audience here today, I wanted to spend no more than 5 minutes, and I promise no more than 5 minutes, since there's a number of you, a number of participant window who I don't recognize and don't already know. Just saying a little bit about what our lab does more broadly before I get really into the topic and the main topic for today. So our research is really guided or animated by this view that sustainability is about more than the environment. It also has inherent economic dimensions as well as social equity dimensions. And so it's these so-called 3 E's of environment, economy, and equity that kind of cut across much of our work. And we also view those outcomes as emerging, not just from technology. So although we are engineers, we don't think just about technology. We really look at the interaction of new technology and human behavior. And so we do a lot of applied travel behavior work to try and understand and anticipate the potential impacts of emerging technologies and how those interactions between technology and behavior can be mediated by public policy. So we try to make sure a lot of our work is policy relevant, answering questions that policymakers are asking or ought to be asking about emerging transportation technologies. So what does that actually mean? I've got 3 concrete examples that I wanted to very quickly introduce. This is one. It relates to electric vehicle infrastructure planning. And this is also work that was led by Chintan Pathak. But it's building on work we've had going on for a number of years, initially with funding from the National Science Foundation to build models of, to build static and dynamic choice models to understand EV drivers' charging behavior. And now we've integrated these into an agent-based simulation of the state of Washington. And it allows the Washington State DOT, its contractors and its consultants to evaluate and compare different scenarios for electrifying different highway corridors around the state. So a user can specify a new charging station with a location and pricing and charging rate. And then we can simulate out what that does to electric vehicle travel and congestion on the charging network around the state. And so this was, again, done with NSF support and then further support from WashDOT. The other big area, another big area of interest for us is automation. And so, and particularly I'm interested in what the potential implications of automating vehicles will be for travel demand. And the hypothesis here is that by relieving the driver from the burden of driving, we reduce the implicit cost of travel time, and that stimulates people to drive more. It's a form of induced demand. So in this experiment, we looked at people's choices between driving themselves in their own car and being driven by someone else in an Uber. And by looking at how their sensitivity to travel time differs across those modes, we can estimate a reduction in the implied cost of travel, which we think we can then use to estimate about a 5 to 15% increase in travel demand in an automation scenario. So as a third example of our work, this is just published work in the Journal of Public Economics that we did in collaboration with partners at MIT and Stanford. We ran a large-scale field experiment, and what we found was that Uber drivers are twice as likely to cancel on passengers when they believe that passenger is Black than when they believe that passenger is white. So this clearly has strong equity implications. So this is just kind of a sampling and overview of those different problems we're working on with equity, with environmental, with economic dimensions, and trying to understand, again, the behavioral impacts of these emerging transportation technologies. So with that sort of shameless plug for our broader work out of the way, and of course, I'm always happy to talk about and to hear from any of you on any of those topics and more. With that out of the way, I want to get down to the main topic for today, which is the tool that we've been developing for reporting of misparked micromobility vehicles. And I'm going to start by talking about why we saw a need for this tool, some capabilities of that reporting tool as informed by interviews with stakeholders, how we implemented it, some field testing we did. I want to show you the data repository we've created, and then walk you through just a couple of illustrative analyses. And then finally close by talking about what's involved with extending this app to cover new markets and new applications. So I think it's worth kind of being explicit here in case you're sort of asking, well, what is the research question? And really with this project, we were aiming to develop a tool that would allow us to gather data and in the future support a large number of research questions. But there's not sort of a single tight question to the work that I'm reporting today. This is really about what we learned in developing the tool, and then hoping to illustrate and demonstrate some of the potential there. And again, by making this data available to others and the tool available to others, we hope to support many, many research projects in the future. And those can kind of fall into two broad categories. One being about, does the development of an app that facilitates reporting of parking problems, increase resident satisfaction? Does it reduce the time needed to resolve problems, et cetera? And then there's also just questions you can ask using the data that are collected from the app. So for instance, what types of neighborhood characteristics are associated with more reports of misparked vehicles? So with that out of the way, I want to start by kind of talking about what are the keys to micromobility. And I realize I haven't defined the term yet, and there are different definitions for micromobility that you will hear people use, but for purposes of this talk, it basically means bike sharing and scooter sharing, and that's pretty much the realizations of micromobility that we have in the US today. And we're particularly focused on dockless services in this case. Anyway, there's some work we did over the last couple of years at the UW where we really in Seattle benefited from a natural experiment, which was we had one of the few dock-based bike sharing systems in the country that was forced to shut down due to low ridership. One of very few cases where that's happened in sort of the modern era. And this was immediately followed about 3 months after that by being the first city in the country to permit dockless bike sharing services. So we have this ability to test a bunch of rival hypotheses about why ridership had been so low on our dock-based system and why it was so much higher on our dockless services. And it's not just a matter of dockless is better than docked. It's really more an issue of sort of fundamental characteristics of the service relating to the scale, how many bikes or scooters you have, density, so how closely packed are they, and coverage area. So the bigger the coverage area and the more dense your locations are, the more utility that service is going to provide to users and the higher your ridership is going to be. That makes sense, right? But what was interesting in this work was that we were able to kind of rule out through a combination of stakeholder interviews, analysis of system ridership data, and a survey of cyclists in the region. We're able to rule out some of these other hypotheses that have been floated and show that it really does depend on having lots of bikes in lots of places. So you can see on the left here a comparison of the former dock-based system called Pronto and the newer Dockless services, and the service area is much bigger that Dockless is covering. We also found when we asked people how well aligned were the Pronto stations with your travel patterns, the majority of respondents said poorly aligned. So it was just not a well-designed system from a ridership perspective. We also asked people, what are Dockless services doing better? And the number one answer was some variation. This was an open-ended question, but it was some variation of, I like being able to drop the bikes off anywhere. So this creates a problem, because improperly parked bikes and scooters can range from sort of a little bit ugly to downright dangerous. And so these are all examples. I believe these are all actually photos I've taken in the course of my own commute to work of improperly parked bicycles, many of them blocking pedestrian or ADA access or curb cuts, as you see. This is not just a Seattle issue. These are some photos that I took on a recent trip to Washington, D.C. And I actually took these and logged these with the tool that we developed. So we see these in Washington, D.C., and I'm currently in France on my sabbatical. And this photo is one that I took outside our apartment in Paris. You can see that they have done a magnificent job of blocking the sidewalk and the ramp at the crosswalk here. Fabulous job. And so this is not something that's limited to the US. And so we find this is not just me being cranky, that we can document that parking problems are a leading complaint about dockless micromobility services. So in that same survey that we ran in Seattle, where we'd asked people and they said the best thing about that Dockless was doing better is the ability to drop bikes anywhere. The number one complaint that people had, what they said Dockless was doing worse, was improper parking. And that was by far the number one response. So number one complaint is, or number one benefit is I can drop these things anywhere. Number one complaint is people drop these things everywhere. So that creates a tension. That tension over in some cases. So in San Diego, people were basically just scooping the scooters up and taking them off the streets. In Seattle, it took a different form. If you can see the photo here on the left, this is a line bike on which the brake cable has actually been cut. And this is on the UW campus. In a city with as many hills as we have, this could there's at least been at least one incident where vandalized brake cables are believed to have contributed to a bike share crash. And it's lucky that someone didn't die in this case. So the improper parking, it engenders this backlash. It leads to these sort of vigilante solutions, and that's bad for everyone. So regular scooter sharing parking. This is the micromobility policy survey from the company Remix. And what you see here highlighted on the left, you're not supposed to read the entire table, but the point is the box on the left, that column is identifying cities that are regulating parking. So you see the large majority of cities that have regulations on bike sharing and scooter sharing are regulating parking. It's the most common dimension to be regulated when cities set these policies. Now, with that said, many cities are doing it, but the details of the rules vary a great deal city to city. There's been some increased research on this over the past year. A team at Vanderbilt here listed at the top, they found that the required cleared width of sidewalk that has to be maintained can vary anywhere from 3 to 6 feet. And that was across only about a dozen cities, if I recall. Patricia Tice down in Florida reviewed cities around the country. and found it's not just sidewalk width, it's many other dimensions that are listed here in the bottom left. There are many aspects of parking that are regulated and regulated in different ways across cities. So the details of the rules vary from city to city, and that's important. Now, how does this get enforced? Well, typically the onus is on the companies to ensure that scooters and bikes are properly parked. But a challenge this creates is that the telematics systems that these companies use that sense and report their location, being GPS based, they're simply not accurate enough to allow you to tell the difference between a legally and an illegally parked bike or scooter. So consider again this image that I shared from Washington, D.C., shown on the right here. If you look at the one scooter that's standing up in this figure, you can very well imagine it looks like there's, didn't break out my tape measure, but it looks like there's about 4 feet of cleared space there. But you could probably change that to 5 feet if you moved the scooter just a foot to the left. Alternatively, it could be oriented differently. The front wheel could be in the same place. The back wheel could be swung around about 60 degrees clockwise, and that would also leave enough cleared space. So it can be a matter of feet or even inches. It can be a matter of orientation that determines legally versus illegally parked, and you're not going to get that through a telematics system. Moreover, illegal is not always the same as causing a problem. So look at the two, the bird scooter in the foreground and the spin scooter laying down in the background. Both of these are tipped over, and that's in many cities an unacceptable way for them to be parked. But clearly the bird scooter is out of the way, causing many fewer problems than the spin scooter in the background, which is blocking the sidewalk coming in from the left. So to summarize so far, poor parking engenders a backlash against micromobility. The ability to pick up and drop off bikes and scooters anywhere is really a key to driving user convenience and therefore ridership. And so those 2 points together suggest that it is important to establish and enforce rules, and that's probably a better approach than closing off entire areas of the city. So if your approach is to say, let's just geofence certain high density areas, well, you're basically at that point closing off the exact areas that people want to go and where they most need to have alternative transportation options. So we need a way to enforce and report problems so that they can be resolved in a timely fashion. Again, recalling that rules vary from city to city and that sort of eyes on the ground are really indispensable for actually identifying problems. So with all that in mind, that has really, that has sort of guided our motivation and our development. I want to note that there's several approaches that are typically used. So what's common to all of these is that they tend to be complaint driven. And that is to say that they rely on residents making complaints, making reports. And again, that has to do with the fact that that's really the best way to know when something is actually causing a problem. Many cities have multiple channels available to residents to do this, but 3 of the main ones are reporting parking problems directly to the companies responsible. Many, if not most cities actually do this as the quickest way to get a report into the hands of the company who needs to fix it. So they will provide an email address and say, email. A second approach is a municipal 311 call center. And then a third approach is a municipal reporting app, or sometimes called a 311 app. So LA and Seattle, and I believe San Diego now have micromobility parking issue reporting integrated into their municipal reporting apps. This has not been costless for these folks, especially when they want to enable sort of direct relay of something from the municipal system out to the company that needs to resolve it. But all of these have disadvantages. So if you're reporting directly to the companies, that puts a lot of burden on residents to keep track of email addresses and have to compose and write an email telling a company the exact location and what the problem is with a misparked vehicle. And from the city's perspective, there's no way for them to track the complaints or resolutions because they're out of the loop. With a municipal 311 line, that can still be burdensome for residents to place a phone call. It also creates work for the people of the city by putting them in the loop and having to relay concerns. The municipal reporting app provides a good user experience, but it does take resources to develop and integrate that into an existing app. And many cities don't actually have these apps, especially small and medium-sized cities. So there are a number of companies that provide these sort of municipal 311 apps. The first three here are all sort of, companies that basically build a business in building apps and software for reporting and managing reports, not just of micromobility vehicles, but general sort of municipal reporting, leaky water lines or bad smells or abandoned vehicles, you name it. And so Connected Bits, Public Stuff, C-Click Fix all do this, often branded under some particular name for the city client they're serving. Fix My Street is sort of an open source alternative to that, but it does require having a competent local team to implement it. And then the final sort of incumbent service here is one called Our Streets. And they serve sort of everywhere in the US, and it's freely available. It does not sort of require the city to sign on, but it is, they have a very generic, very simple list of violations that's not tailored to the particular rules of the city. The only three things you can report through Our Streets are a broken bike or scooter, one that's blocking the sidewalk, or one that's tipped over. And it's not clear to me from, and I have not spoken with them, but from the investigation so far, I can't tell what they actually do with the data, except they appear to report it more to community advocacy groups than to the companies for resolution, but would love to hear more about that. Anyway, so our premise, our motivation here was that a dedicated mobile web app could provide a simple, easy solution that could benefit governments, service operators, and researchers. It could make reporting easier for residents. It could reduce workloads for city staff, eliminate the need to have a municipal app to integrate with, but enhance accountability through having a consistent record of reports. And so we went out, we talked to a number of sort of government workers, folks who are typically responsible for managing and regulating bike and scooter sharing programs within their borders. And we interviewed them with two basic questions that were essentially, how do they currently handle reporting and follow-up? And secondly, what capabilities would they want to see if there was some kind of app that were designed to facilitate this? What we found was people came back with different things in response to those questions. And so we indicate in this table which features people said were necessary and which ones they sort of said, oh, that would be nice to have. If an empty cell doesn't necessarily mean that that city did not want that feature, it means they did not mention that unprompted. So we were not sort of feeding them a list, we were sort of seeing what they came up with. And so this sort of summarizes, you see some, the first two cities here had a lot of ideas, some of the others were much more sparse. But taking that into account, the background work us to be able to log and report location, time, the type of issue or the rule being broken, and the company responsible. And that it would be important to document it with a photo. And we wanted something that would be easy and quick to use and sensitive to location. Again, since rules vary depending on location, we want to be sensitive to that. So the basic sequence of steps that we have is a user takes a photo and identifies the location. They classify the type of violation in question and the company responsible. And then optionally, they can give us an exact ID on the vehicle. Anyway, we chose to deploy this as a mobile web app because as opposed to a native app or a couple of native apps, because the mobile web app allows us to use the same code base across different operating systems. It eliminates the need to seek App Store certification, and it avoids users having to download and install anything. So from our standpoint, it was a lower barrier to entry for us, both on the development side and a lower barrier for potential users. So that's why we went with the mobile web app approach. One of the students on the project, one of the RAs, Borna, developed this video demonstrating the app. So I'm just going to run this quickly, and it's about 2 minutes, and I'll let it go.
Have you ever noticed bikes or scooters being parked badly and you didn't know how to make a complaint about it? Whether they are blocking the sidewalk, not parked upright, placed on vegetation, or even parked in your private property, there is now an easy way to make those complaints. Misplaced Wheels is an easy-to-use web-based application. Go to misplacedwheels.com, select the location of the bike or scooter on the map, and press Continue. In the next page, upload a photo of the bike or scooter. And then select parking issues that the bike or scooter is violating. You can select one or as many violations that you deem suitable from the list. There is a More button which shows you additional infractions as well. Also, select one or more companies which are related to your complaint. Press Continue, where you can finally upload the QR code optionally. You may add additional notes as well, and your report is now complete. In this page, you can choose to submit a new case as well. Misplaced Wheel.
So that gives you an idea for the flow. It's pretty simple, and it's relatively comparable to the sort of sequence of steps that is involved with a Municipal 311 app. But again, we're avoiding the need for a native app, and we've got something that is, as I'll show momentarily, very easily adapted to new jurisdictions, to new markets. So I've just showed you kind of how the user can generate these reports, and I want to talk about what we do with them. Well, the user reports are recorded in a database, and we have a repository web viewer which is at misparkrepo.com. You're welcome to take a look at it. I was going to go over there momentarily and show you around. So that's one thing we're doing with those. We've also built the capability, but not yet activated. We've built the capability to auto-generate an email in a standard format, like in a JSON format, with the crucial information, so the coordinates, the type of problem, and then send it to the company responsible along with a photo, so that they can receive that information in a structured format that's more amenable to automated processing than, say, an email that's just been written by an angry neighbor. So we've built that capability. We've tested that capability. We do not yet have it turned on because of some of the anti-spam rules around our AWS hosts, but we're ready to turn that on as soon as we have city and company partners that are ready to receive those reports. So we field tested the app in Portland and in Seattle, and we really did this more as an audit study to go out and experience the app. So in Portland, we found 21 zip codes within the city of Portland that contained 20 or more scooters. This was back in July. And we cluster sampled 9 of those and then audited all of the scooters in the sampled zip codes. And that amounted to 630 scooters that we were able to audit over 4 days. In Seattle, there were fewer bikes deployed at the time we were doing this. So we were able to basically take a census of all shared bikes in the central and northern sectors of the city. That was about 167 of them over 2 days. And the data we have right now are recorded in a database, and they're accessible through this web-based repository. And I wanted to share just show you around there. I'm going to refresh the screen. So this is MisPark repo. This is our web viewer for the data that we've collected or that others have reported. And so you can see we can zoom in on Seattle or on Portland here. This is where we have the largest number of reports. And we can click on a point on the map to see a photo, the photo that was submitted as part of that report. And down here, it actually identifies down here which issues were reported as being related in this report. So this was identified as reducing pedestrian clearance, disabled access, and being tipped over. We can also, we can filter based on vehicle type, say e-scooter. We can filter by company, say we want to only look at Lime. And then we can filter by, we have a severity code. So each violation type can be assigned a severity code from 0 to 10. This would be done typically in consultation with a city partner to determine which infraction types they deem to be of greatest priority within their city. And so we can apply those filters and we can see how things look. We can create bar charts showing what those violation types are, showing the distribution of severity codes. And if we're interested in looking just at a portion, say the Pearl and downtown districts in Portland, we can basically define our own area of interest here. And like so, then filter down to just that area and now see what are the distributions of infractions and severities in that area. We can also export the data here as CSV, PDF, or XLSX. So we can download that data from the repository for offline analysis if we wanted to analyze it in some other tools. So for example, if we wanted to do, here's basically a cluster analysis of hotspots. We can maybe, in this case, the color coding of the points indicates when they were reported. So darker colored points are older and the lighter colored points are newer. Of course, at the moment, all this really shows you is, you know, the order in which Borna collected data. But you could imagine that if you were collecting this over a period of months for a city, you could look at whether any hot spots, whether any high density areas tend to move around and evolve over time. Finally, we have something similar here where the color of these bars indicates the severity of the infractions, the average severity, and the height of the bar is the number of infractions. And you can see how these are evolving over time in different parts of Portland. So these are just a few of the things that if you were to download these data, you know, it would enable much more offline analysis. And then a final example here, this is from Seattle, you know, overlaying our report data over a topographical map of the city showing elevation. And one of the things you see, it's not surprising, but one of the things you see, of course, is that the bikes tend to end up at lower areas. That's just the findings. But again, our goal here was not to pursue any of these questions in particular, but to demonstrate, you know, the potential utility of these data and the tool for collecting these data. So I wanted to say a bit about what's involved with adapting this to new markets. So it's relatively straightforward, and in part that was facilitated by the amount of care that we, and by we I mean Chintan, put into designing the relational database. So it's very easy for him to create a new city or a new region in here that we're going to support. Basically, what we need is a vector boundary defining sort of the area in which a set of rules is in force. And then an associated list of infractions and severity scores. So within that boundary, within that area, what are the different infraction types that we would want people to be able to report with the app? And, you know, in consultation with a city partner, we could assign severity scores to those. And the final thing, of course, is we need to know who the companies are and what types of vehicles, bikes and or scooters, they're operating in that market, so that we can relay appropriate reports to them. So currently we've implemented this for a number of jurisdictions in Washington, in addition for Portland, Oregon, for San Francisco, and for Washington, DC. I want to say, you know, one more thing that we can do, as we did in Portland, is we can readily use this as a tool to support audits. So cities like Seattle are undertaking systematic audits. This is another way to enforce and keep track of compliance with parking rules, is to periodically do audits of compliance and actually go out and survey every bike within the city or within certain zones of the city. And to do that, to keep track of that, you can use a tool like Misplaced Wheels to automatically digitally record those reports and the associated photos. And so to make this easier, we included an option in every infraction list for no issue. So if you were using this for an audit, you want that option to indicate when there's not a problem. The only kind of caveat here is if you are in an area where there's sort of users out in the wild doing this as well, then you would want to have some way to distinguish your audit reports from those user-generated reports. So one thing, because this is, we're open sourcing this, one thing would be to go and just sort of create a separate implementation with a different URL and different database where you'd put your audit stuff. The other kind of hacky, easy workaround is in that notes field on the final page for each report, you could put into the notes just, you know, some kind of message or some kind of flag that you could then go back and use to filter and identify those ones that have been generated as part of your audit. So we see that as being a potentially really useful application for this as well. We do see some opportunities for improvement. You know, some of them relate to scaling if we want to be able to support larger numbers of users. Another, I think a big one from a research standpoint is there's potentially a lot of really fun and interesting things you could do with some machine learning on this. You know, being able to validate and check quality on images, maybe identify vehicle type or company or possibly even infraction type from those images. If we get a large enough, you know, and each of these submissions is essentially a labeled image. So if we get a large enough number of those, we may be able to do some cool stuff in that regard. And then also on the back end, there could be some opportunities for you know, helping cities manage and track resolution of these issues. So there's a lot of, you know, potential to build on top of this as well. So to summarize, you know, we've developed and tested this mobile web app. You know, we can use it for reporting misparked micromobility vehicles. We've got this repository and visualization tool, and again, tested but have not yet turned on the ability to, you know, auto-generate emails to relay these reports in a structured fashion to the companies responsible. And finally, you know, the app can be adapted, you know, for use either by the general public or for, you know, systematic citywide audits, and can be easily adapted to new markets. So I want to thank again C2 Smart for supporting this. Also not on this slide, but Borna and Chintan for their hard work on developing it. And of course, many officials, government folks who shared their time and their insights with us as we were thinking through the functionality that we wanted to put into this and giving us feedback along the way. And thank you all for your attention. I'd be happy to take any questions that you have at this time.
Okay, Professor MacKenzie, thank you so much. That was really great. So I guess, well, yeah, as Professor MacKenzie said, please feel free to use the Q&A feature at the bottom of your screen to type in any questions. In the meantime, I was just wondering if you, I know you approached some agencies in the design of this app, but have you approached them now that you've have this like active pilot going on?
Yeah, so and this is one of the things it's a little disappointing. Everyone was super fired up, and it was kind of pre-COVID or pre being stuff really being bad with COVID. Folks were really fired up, and we have circled back with them. We've shared with them the tool as it's developed. We don't yet have anyone subscribed to use it, but we're sort of continuing to follow up with new city with folks we've already talked to and trying to contact new city partners. Also seeing if we can, we're also sort of pursuing angles to try and generate some organic use just among the general public.
Okay, I have one question from participant. So what about spinning off to usage by a bike share or micromobility operator?
Sorry, I couldn't quite hear that, John. Could you repeat it?
Sure. So one audience member asks, what about spinning off? The concept of spinning off to like for implementation by a bike share or micromobility operator, would they find this useful?
Yeah, I think they might, and I think there's a number of different ways you could go. I certainly don't have the bandwidth probably to try and build a company out of this, but we have talked to Lime about it, and I actually was in a meeting with Uber and accidentally left this background, this Zoom background up, and then it had some explaining to do. And so we've been in a couple of the companies are aware of this, and there's sort of, and I think we kept it quiet, sort of not wanting to ruffle any feathers. But at the same time, I do think there is a potential benefit in it for the companies, right? So they are responsible, whether they like, so the sort of narrowly self-interested view would say, look, you might cynically say they don't want to hear these reports. But I think the more enlightened self-interest is they do want to hear these reports because ultimately they are responsible. And again, in cities like Seattle, and if more cities go to this, they can be audited at any time. And so they need a way to know where these problems are. And it's in their interest not to have a public backlash. So tools that make it easier for residents to report problems and for those problems to be resolved in a timely fashion, I think are ultimately in the interest of those companies. Now, Lime, for instance, allows you to report a parking problem through the Lime app. And that's great for me as a Lime customer. But if I'm just some resident who's kind of irritated by these bikes and scooters all over the place, I don't want you asking me to download Lime's app so that I can report a Lime scooter, tipped over on my lawn. That's just kind of rubbing salt in the wound. Moreover, cities like Seattle, this is not so much an issue, but Portland, where you have multiple companies, Chicago, where you have like 10 companies, DC has a large number of companies operating. It starts becoming pretty unwieldy for for users to sort of have, if you're not even a user, you're just a resident who wants to report these things. You don't want to have 10 scooter company apps just for reporting problems. So I do think it could be in the interest of these companies to see something like this developed. But, honestly, we went through NSF I-Core this summer. And, the first thing we realized that we'd done wrong is we went and developed a solution, before we talked, we're supposed to talk to people about the problem. But also as a researcher, sometimes you just want to go out and build something. And again, we see this fulfilling potentially multiple purposes. So if it doesn't gain traction commercially, we still see a lot of potential for it to be useful to researchers and cities who want to run audits.
Yeah, and also, I was thinking, you mentioned the machine learning aspect, which I didn't even think of, but you're also just able to geolocate bikes and scooters across different companies with this app. And I think that's very interesting. Like from a research perspective, you have this now like database of exactly where the scooters are by which company.
Right. So we have that option to, so that sort of optional feature at the end of scanning the QR code. We didn't make that a mandatory requirement because it didn't seem like it was essential information for a company to resolve the issue. But we do think that in some places it might make sense to make that, to include that. And the reason to get that vehicle ID is if a city wants to follow up, the city then, they've got a record, they can see that this is the same scooter that's generating, it's now gotten its third complaint over the course of 2 days. This is not just, oh, someone always leaves it here, leaves a scooter here. This is the same scooter ending up, or the same scooter has not been moved. Same issue, same scooter, right? So there's a little more accountability, but also from a research standpoint, it gives us something kind of cool if we can start to track, you know, the same scooter appearing in different locations because we've got that QR code that helps us identify it. So there's opportunity there as well.
Sure. Very cool. So I think if there are no more questions, I just want to say thank you, Professor MacKenzie, and thank you everyone for attending. You can feel free to follow C2 Smart on Twitter, check out past webinars on YouTube, join our mailing list, and definitely join us for our next webinar on October 29th featuring Professor David Coit from Rutgers University and his work on infrastructure degradation models. Thank you, Professor MacKenzie, again, and thank you everyone for participating.
Thanks, John, and thanks everyone.
Take care.